Good afternoon, or evening, or morning, or whenever you're watching this. It is January 21st, 2022. I haven't done one of these videos in a while, but I thought I would do a little quick long-range forecast here for the end of January into the first half of February, because I know that I've talked to a couple people that I know about the possibility for lower snow levels, possibly even lowland snow coming up again. And this seems to be likely now, not necessarily the lowland snow likely, but likely that we're going to get some cooler air, some precip back here in the northwest, and a setup that might favor some lowland snow if things go right. And again, we don't know exactly what's going to happen yet, but we do have a much better idea now what the setup is, how things are going to set up. And it's just because more and more models have come into this agreement. So the long-term climate forecast system, the Gfs model, that is run by the United States. This is a long-term, I guess you can call it a model that runs out about 30 days. So it's actually indicating this possibility as early as I don't remember, early to mid-January. And I told a couple people that was doing this, and it actually got the Christmas range set up for snow weeks in advance. So that doesn't necessarily mean anything, but it's kind of interesting that that's actually been looking at these long-term patterns, and so I've been looking at it a little more. It also helps that we're in, well, when I say helps, what I mean is it helps to know that we're in a La Nina, and I'll post a separate entry on my blog about, at least I hope to, what's called the Pacific Decadal Oscillation, PDO. It's actually related to La Nina, and it's when, I'm just going to draw on this map, so ignore the colors underneath it, but it's when temperatures north of 20 degrees, so north of this line, that's not good because I can't see it. Let's see. North of approximately this line. Again, ignore everything underneath here. It's related to the temperatures in the ocean to our west, north of this 20 degree line. La Nina mostly focuses on the temperatures south of here, and west of South America along the equator. So the Pacific Decadal Oscillation looks at those, and when we have a positive PDO, that's what I'm going to use as an abbreviation for this oscillation. We usually have warmer than normal ocean temperatures. So I guess I should keep it off here to the ocean over in this area, and cooler than normal over in this area. I know that I overlapped here. The warmer should kind of stop here. When we have a negative PDO, we normally have cooler than normal temperatures here in the northeast Pacific Ocean. It's kind of more like this, and then we have warmer than normal over here to the west. And like I said, that's kind of related to El Nino, La Nina. They kind of look the same, and so they kind of stay in step with each other. And this is the second straight La Nina winter we've had, so that's one reason why. But we actually have the most negative, in other words, the coldest La Nina, the coldest sea surface temperatures in this area relative to normal than we've had since 1955, and I will make a post about that. The October through December time period was the coldest sea surface temperature relative to normal in this area since the mid 1950s, and usually the Northwest favors colder air and more snow when we have a negative PDO like this, especially if it's medium to strong. So that kind of helps to know when you're looking at the long range that it might be a little more likely. Anyway, let me show you what's currently happening, and then what we're looking at here in the future. So over the Northwest right now, this is the European model from this morning, and we're looking at again, I already showed you this, but without actually referencing it. But here is the Pacific Ocean basin here. So the west coast of North America is here, Washington is here, Oregon is here, California is here, Alaska is here. This is Asia over here. I'm just trying to give you a reference about what you're looking at. Here are the Philippines, and here's Japan. Hawaii is, let me just circle this somewhere. Here's Hawaii right here. Alright, so just to give you a reference of where we're looking at, and this is like I said, this is the European model. This is their actual analysis that's valid this morning, Friday, January 21st. And this is the upper air pattern. So in the upper air pattern, we have this. I'm going to try to use, let me see if I can use a different color there. 1 second. Black may work. I think it's the thickest it goes to. Yeah. Use a highlighter. Black highlighter. There you go. There we go. That's kind of what I was looking for. So we have this big ridge just off the west coast, which is basically all this warm air that's moving north. Is basically what a ridge is. So a lot of the month of January, we've had some colder air moving into the east. This has kind of been the opposite of what it was in December, and we've had this warmer air moving north. So we've kind of had this drier pattern in January for the most of the month, not the beginning of the month. So mostly after maybe January 10th or something. And it looks like this pattern is basically going to continue through most of the rest of the month here. Interestingly, we also have this feature right here. This is a low pressure system east of Hawaii that has a low potential. It's actually kind of a very low potential now of becoming a subtropical storm very early in the year as it moves west. But like I said, it's going to encounter a lot of wind shear as it moves west, so the odds of this actually becoming a subtropical storm are rapidly becoming lower and lower here this afternoon. Okay, so anyway, so west you see this kind of wavy pattern in the atmosphere. It looks like this. So we have these little ridges, we have these troughs right here in the atmosphere. We have this one in the eastern part of the United States. And within each of these troughs, we have low pressure systems, mostly on the east side of those troughs, and the west side of the ridges, which is where they like to form, and high pressure systems, surface high pressure systems on the east side of the ridges, west side of the troughs. All right, so that just gives you an overview of the general atmospheric pattern this morning. And what's going to happen with this ridge in the next few days is it's basically going to, there you go, okay, is just going to build a little bit eastward, become a little broader over the west coast of the United States. So for most of the west coast here, which is where I am when I'm making this video, we're going to see continued dry conditions. These ridges are associated with dry air, sometimes warm air. In the wintertime, it's not so warm in the valleys west of the Cascades, and that's, I'll tell you why in a second. But along the coast is where they're going to have the warmest air with this ridge. Not only will they be closest to the center of this ridge, which is right here, but they also aren't in valleys like the Seattle area down through the Willamette Valley. Often in these situations, we end up getting fog. We end up getting low clouds sometimes. In the summer, if we see this, it's going to be very sunny. But in the winter, we end up getting moisture that gets trapped at the surface, which leads to fog. At night, when we get radiational cooling at night, and then during the day, sometimes those low clouds and fog take a while to burn out, and the days are so short at this time of year, even though they're actually longer than they were a month ago. They're significantly longer already. Maybe, I don't know about significantly, but they're definitely longer than they were a month ago. It's a lot harder for those low clouds and that fog to actually burn off during the day. But the other reason is because with these ridges we have sinking air above the surface. So if I use this right side of the screen, we have all this sinking air above the surface, which is called subsidence. So this air is kind of subsiding down to near ground level. So if we have the ground right here, then this air that is sinking above our heads basically traps all this low fog and this moisture down at the surface. These black dots are supposed to represent moisture. Anyway, water in the air, so you kind of know what I was planning to do here. But anyway, what happens with these two is this sinking air also traps a lot of air pollutants. So we, here in the Willamette Valley of Oregon, where I am, we get a lot of, we currently now have an air stagnation advisory, which means this air at the surface is not going to be able to move anywhere. It can't mix upwards. So we end up getting all these air pollutants down at the surface that get trapped, any low clouds, any fog. So sometimes during the days here, we might not warm up so much. And this is more likely early next week. It's more likely that in these kind of patterns, we usually get sun at the beginning, and then the more and more time goes on, the more and more low clouds and moisture and fog and air pollution get trapped down at the surface. So we're looking mostly at next week for this air stagnation. This also means during the COVID period that it's more likely that any now this is not quite the same as air pollution, but being outdoors, if you're near someone who you know has COVID and you're all without masks, it's going to be a little more likely that that you might actually catch it, because there won't be air moving, and you won't have air that's actually mixing upwards, and so a lot of those aerosols and air pollution, even those little droplets that come out from your mouth when you're breathing, can get trapped and kind of linger in the air longer. Eventually, they will disperse with the air, but it'll take longer. So just to keep that in mind. Again, that's more early next week, but it'll start this weekend here. All right. So anyway, that's what's currently. This is actually a 48-hour forecast. This is a forecast for Sunday morning from the European model, and then into next week, that ridge will kind of weaken a little bit, but it'll still be there here on the west coast. What we're looking at, what we're looking at in the long term. Let me go back just a couple days. So this is Sunday morning again. We're actually looking at this ridge here that's going to be emerging off the west coast of Africa here in the long term. And in the European model here goes to 24 hours at a time, so it's kind of hard to follow a little bit. But if you're following this, we're looking at this ridge that's going to be, like I said, emerging off. This is now over Japan next Tuesday morning, and just east of that we get some areas of low pressure that's develop along this It looks like, it kind of looks like a baroclinic boundary, but it may not be, just because there is a trough here, and you probably don't know what baroclinic boundary is, but I'm just thinking to myself here. Anyway, those of you who are watching this video, so what happens is this low kind of strengthens. Here's this ridge here now starting to move over the ocean, and we have a stronger low now. Basically the very western tip of the Aleutian Islands, and it has this nice strong cold front, which is basically what I mean, a baroclinic boundary. It's basically the difference in between. It's a boundary that feeds off the difference between warmer air and colder air. So along that boundary, we're actually going to see another area of low pressure system, another area of low pressure form. So let me go forward here in time and kind of see it right here. It's actually kind of forming here, so that boundary is now way up here. Here's that ridge that we're looking at. So let's go back to the west coast here. Now we see this big ridge here on the west coast. It's weakening a little bit right here, with a trough that's kind of moving in, but we're looking mostly at this low pressure system off the west that will start to really weaken it. Okay, let's go forward in time. 24 more hours to next Saturday morning. So now our low has currently strengthened a little bit. This is that low that started developing along that boundary. Now, at this point, this low is way up here. We have another low that has started to develop here. Our ridge has now strengthened quite a bit and is moving into Alaska. And there are a lot of basically every model now is starting to do this, where we get this ridge now weakening along the west coast, and this new one building to the west in Alaska. So at this point, next Saturday, we're still looking at a ridge over us. So this is over a week from now. So we're going to be fairly dry for the next week with this ridge over us. What's going to happen is this low pressure here, the low pressure system, which I just kind of outlining, but you didn't really see that, right here, in the Gulf of Alaska at this point, early next Saturday morning, in this ridge that starts building behind it, is going to move into the northwest, and this is going to start a pattern change here in the northwest part of the country. So our most ideal snow events come when we have a ridge over Alaska like this, not necessarily exactly the way that I'm drawing it, and then a trough moving northwest where we get where we're able to get cold air pulled into the northwest, but we don't want that trough too much over water, or else we get onshore flow still, and it stays too warm for the lowland snow. And when I say we don't want it, that's assuming that you want snow. I'm just talking about what the ideal setup for the lowland snow is here. So like I said, I didn't draw this completely right, but probably more like this. Alright, so anyway, I just mentioned that so you keep it in mind. So let's go for 24 hours more in advance. This is early next Sunday morning. So at this point, we start seeing this ridge now starting to build into Alaska. We start seeing a general pattern where we have all this cooler air starting to move offshore. And then 24 hours in advance, 24 hours from that, this is now January 31st, the morning of January 31st. And again, this pattern may evolve completely differently than this. I mean, it's going to evolve where we have this ridge over here, and we have some cooler air over the west. But exactly how it evolves, we don't know for certain yet. So this low has now moved in northwest, and so basically this whole ridge has now broken down over the west coast, and we're going to start getting some cooler air. Now, initially, it's going to be rain in the lowlands, of course. some mountain snow, but it's probably going to start bringing some rain back to the northwest. It's going to start to lower the snow levels a bit. But what it does is it sets up a general pattern where we might be able to get lowland snow if we get the right conditions for it. And there are some models that are indicating that. So let me go back. This is the GFS, the U.S. long-term model run, and this is next Saturday morning. So it's doing the same thing. Like I said, all these models starting to do the same thing. We now have this ridge in Alaska. This is Sunday, January 30th, and we start. This low is moving down northwest. Go into the 31st now, which is right here basically, and we have this general pattern now. We have this big ridge over Alaska, and we're starting to see that snow type setup. Now this is still just me looking at this. This is still probably very likely not cold enough for snow yet in the lowlands. Probably some in the mountains, but it's really not cold enough. It looks like we may have a little too much onshore flow. What it does is it sets up the pattern that if we continue into early to mid February and this pattern does not break down, then we could get more. Then we could get snow events in Northwest. So let me go forward in time. This is now the very long-term GFS, so this doesn't mean this is going to happen. But when we have this very strong high-pressure system starting to set up to our west, and we can get this ridge going up to Alaska, then we have the potential for things set up right, low-pressure systems that might develop here on the west, kind of track over the top of the ridge and then down the west coast. So they track right down the west coast, then they can bring colder air into the northwest from Canada through the river valleys and bring possible snow into the northwest if they meet low pressure system off the coast. Now again, that's a lot that we need all at once, and this is not saying it's going to happen, but there's a chance that could. And this GFS U.S. model, long-term U.S. model, actually wants to do this in the long term, and it's kind of wanted to. So here's this energy that's right there that's moving over the top of that ridge, and what it does is actually builds this ridge now further to northwest, brings this low pressure system right into the northwest. So let me go forward in time. You might have already actually seen it what I had. So this is the long-term U.S. model, and the GFS, which is the long-term U.S. model, has kind of wanted to do this. Here's that ridge now, which amplified to the west, and now this low pressure system has moved to just off the northwest coast of the United States, pulling some cooler air into the northwest. And if we get that cooler air meeting with a low pressure system off the coast like this, we could end up getting some lowland snow. This is on February 4th actually, 10 p.m. on February 4th in the northwest. And like I said, it's not saying this is going to happen, but this general setup and the general pattern change that's going to happen may set the stage for an event like this in early to mid-February. So I've been looking at this. This is the afternoon GFS model that's been coming in, and now I've been watching this to kind of see what it's been doing. Just a couple notes here. I moved to a North American view, so it's not showing the whole ocean anymore. Here's Alaska here, Washington's right here, Oregon's right here, California's right here. So that's the West Coast. So just to let you know that I moved to a different view. And also these afternoon runs, I don't necessarily like as much. That GFS model that I just showed you, the long-term U.S. model, by the way, came from last night. The morning round one had the general pattern change, but it was a little more messy, and I kind of wanted to show you that what it was doing in the very long term, the pattern that it could set up. So anyway, this is the afternoon one that's currently coming in, so I haven't seen this one beyond next Wednesday night, which is right there. I know this is Thursday, but that's London time, so you subtract 8 hours, and you get 10 p.m. here on Wednesday the 26th of January. So I haven't looked at it beyond this point. And I don't like these afternoon model runs. Again, this is from 18Z, which is 6 p.m. in London time. London. So this was ran off of model data that came from 10 o'clock this morning, and it's currently almost 3 here. So this is kind of this is the time of day it runs. But I don't like these afternoon model runs as much because they don't have as much data that feeds into the start of the model run, because most of the upper air data comes from so basically weather balloons that are launched from the surface and go up into the atmosphere, measure what's going on up there. Those are launched at 12 p.m. and 12 a.m. in London, which are the 12Z and the 0Z model runs. So these that come in at these 18Z and the 6Z, 18Z, 6Z are not necessarily as accurate. They're not necessarily bad, especially because we don't have a lot of the upper air data anyway to our west over the ocean. So I mean they're still helpful to look at. It's just sometimes I put a little less confidence into those than I do into these 12Z and 0Z runs. Anyway, with that said, I'm going to start looking at this because I haven't looked at this one yet, see what it's going to do in the long term. But let me just make some notes here. This is next Wednesday night. Again, here's our ridge. It's going to be over us pretty much the whole week. I think this low, I have to go back, but this low might be the one that starts to change our pattern here. I have to go back or go forward here. And so here's that ridge still staying over us. And, again, the Gfs looks kind of messy in terms of the fact that we have multiple lows out here and these multiple pools of cold air, which is kind of what I was talking about when I said, that it looks a little messy. Not that this can't happen, it's just often you don't have these multiple areas of low pressure and the cold pools that close to each other. But here's the ridge starting to build in behind those lows. Next Saturday morning, here's our ridge starting to move off to our east. The one that was kind of over us for a long time. So let's see this now. This is 29th, Saturday 29th. This is now Sunday the 30th. And the GFS has been kind of doing this where it builds this ridge, but underneath that ridge we get these areas of low pressure, multiple areas of the cooler air. So it doesn't consolidate into one and move northwest like some of the other models do. And I'm not saying that might not happen, but let's see what it does here. Right, this is now the furthest it goes at this point. This is 4 p.m. on January 31st. It'll go further into the future here, but this is as far as as we can currently see the model data. It hasn't shown up beyond here. All these gray numbers have not shown up yet. So all these darker numbers, this is the number of hours into the future. So 246 hours into the future is 10 days and 6 hours in the future. So all these gray ones will load here eventually, but they haven't yet. Anyway, so at 4 p.m. on January 31st, we get this ridge here over Alaska. So that's the ridge that we're looking at, and then we get this general, in terms of the GFS here, kind of messy. I say messy because you get this area of, get this cold pole that's kind of distinct from this. It's not really that messy. It's just It's just a word that I use. But anyway, it's not, consolidated into one area. But anyway, the point is that we start getting a pattern change. We no longer have this large ridge over us that we did before with all this warm air. We now start getting a little bit of colder air moving northwest. Again, this is not, I draw the arrow, but this is not necessarily nearly cold enough to bring any kind of snow. We still got onshore flow actually here, but in general, the atmosphere, we start getting this pattern change. So we start getting some rain in here. This is just what it looks like from this model run. Now, I see that I have new hours here, so let me look at those. Go back one just because that one is currently added. Except I can't seem to get on here. 1 second. I can't seem to get back to my arrows here. I'll show you some other model runs. ROS not doing this. Okay, let's try that. There you go. Okay, so now going through to the morning of February 1st now. Okay. And I'm also noting, and like I said again, I don't necessarily like these afternoon runs that much either, so I don't put a lot of stock into these, but we still see this ridge here, but it's not that strong, and I say that because we don't see these yellow colors or the orange colors that I think we did in the European model. Let me go back to the European model here. Yeah, see, in the European model we saw this. Let me go back. Let me do the same one, but go to North American view. That way we can make a comparison a little bit easier. So this is the same model that I just had up, but it's the European view. And I guess the European isn't is also kind of a little disorganized. It has this second low, has this cutoff low. But you see this cutoff low looks stronger because it has that yellow and that light green. That GFS model that is currently coming in, you don't see that yellow. You only see a little tiny bit of light green. So this GFS model that's currently coming in isn't as strong with that ridge, and that's kind of what the European model has been doing. And in general, the European model is usually a little stronger anyway. So while I'm waiting for that to come in, and I'm still on this video, I'm going to go to some other models. I'm going to go back to North American view here. That's the long-term GFS one that I showed you last night. That's actually bringing in that cold air into the northwest. This is an ideal pattern for some cold air in the northwest and warmer air in the eastern part of the country, which is actually also normal for a negative cold PDO that I talked about earlier in this video. So let me show you a couple other things here while waiting for that to come in. So I already showed you the European model, which is probably the best model in the country. So let me show you. This is CMC. This is actually the Canadian Meteorological Center. So at 10 days now, which is as far as this goes out, we see this ridge building in, but it's not nearly as strong as the European. And then we start seeing that cold air that's going to start forcing the pattern change. So the Canadian model is a little slower. Actually, I see the Canadian model has this strong storm here along the east coast that might bring some snow up to here. But anyway, that's beside the point of this video. But the Canadian model tends to be a little slower and a little less accurate. That doesn't mean that it might not come until a little bit later. Often these models will show pattern changes in the long term, and then those pattern changes will kind of be delayed until they actually start to come into view. So that's why I'm saying more like early to mid February. Early to mid February, I think, is more likely than late January into early February for any kind of major pattern change, possible snow here. But anyway, because usually when they start indicating this, it usually happens. It just happens a little bit later. than they do if they start indicating this in the long term. So that's the Canadian model. This is from the U.S. Navy, and this only goes out 180 hours. This only goes out to January 28th, but we start seeing this low here and this ridge behind it that's going to start to change the pattern. So we still see the same kind of starting to be a setup. Icon, this is a German model, but it only goes out to 120 hours, which is only 5 days. So we see this ridge over us next Wednesday morning. But that's all it goes out to. The JMA, that's the Japanese model, Japanese Meteorological Agency, I believe it is. And here on the 29th, the morning of the 29th, we see that ridge, and we see that low starting to set up. If I go back 12 hours, I think it's 12, no, if I go back 24 hours, that ridge was over here, and that low is here, so we see it just start to move that way. So it might not move southeast into the northwest quite yet. Let's see. And then ensembles. Ensembles, if you aren't familiar, if I haven't talked about those before, they're basically a collection of a whole bunch of models that were all run, and then they're averaged. So this first one, for example, is the European ensemble. That's what E stands for, European Prediction System. And it's basically the European model run, I can't remember how many times. Usually it's like 25 times or 24 times or something like that. It depends on the actual ensemble system. And they take the average, and when it's run every time, they basically differ. So when you take observations in the atmosphere, there are always errors. They could be measurement errors. They could be other kind of errors, instrumentation errors. But there's always like a margin of error that exists in any kind of measurement. So a lot of these ensembles, they will vary the initial atmosphere a little bit based on what the atmosphere might possibly look like in the future. Sorry, what the atmosphere might possibly look like now. And then they run that model again based on slight differences in the current observations. And if you differ things slightly now, then you usually get larger. Those errors get magnified through time. That's called chaos theory. It's like if you ever heard the term, a butterfly flapping its wings in Brazil causes a tornado in Texas. If you disturb the atmosphere just a little bit now, that may get magnified in the future. Again, that's called chaos theory. So that's what these ensembles do, and so they get this wide range of different possibilities that might happen in the future. And when you look at these averages, mostly for extreme events, not necessarily in average, and you start seeing that more deviation from average actually starting to show up, then it's more likely it's going to happen. So this is the European average now for next Friday morning, and now we're starting to look at, this is the furthest it goes. This is the morning of January 31st, and even our ensemble average, which has a lot of different possibilities of what the atmosphere might look like, has that ridge, and then has more of a trough of the northwest. Again, this is probably not going to initially pull enough cold air in the northwest for any snow in the lowlands right away. I'm not saying it's not possible. There's a possibility. I just don't think it's going to happen that early. But like I said, I'm not saying it's not going to. We just don't know all the details. This doesn't look like this is going to be cold enough initially for this first low to actually pull in enough cold air. Again, we'll see how that goes in the coming days. I'm just looking at the general pattern that it's going to set up, and but like I said, it might set up this pattern that if this ridge is strong enough over Alaska, it might persist for a little bit of time, and then we might get these low pressure systems that can actually track down the coast, and the more that happens, the more cold air that might be able to be pulled closer and closer to the Cascades, and then eventually through the Cascades. Again, we'll see how that's set up. But anyway, the long-term European model, long-term European ensemble does that. This is the long-term Gfs Ensemble, and this is actually the afternoon model running, so it only goes out through 150 hours next Thursday at this point. So let me go to this morning's long-term Gfs Ensemble, and this is now February 1st right here, and it's doing the same thing with this ridge over Alaska, pulling cooler air into the northwest. Generally, a pattern change here. Long term, this is I believe this one's a long term Canadian ensemble, and it's a little bit different. Again, the Canadian ensemble isn't the most accurate. But it still does have the ridge over western Alaska and the start of a pattern change northwest. Again, this is the average of a lot of different models. So often this particular one is not going to happen. It's just there are a lot of different possibilities, and this is just the average of all the possibilities. Our long-term climate model. Now this is the long-term climate model, and this is basically weekly average departure from normal in terms of the height in the atmosphere. When I say height, this is how high you have to go in the atmosphere to reach an air pressure of 500 millibars. So the higher that you have to go, which is generally the more purple areas, it's actually the higher these black lines are, the warmer it is in the atmosphere in general. So you see here in the eastern part of the country, it's colder. These purples and these blue colors are actually the departure from normal. But anyway, for the week of January 21st through January 28th, which is this coming week, we see this big ridge just off the west coast. Very high departures from normal, so very warm in the atmosphere as a whole. And then this long-term climate model indicates, okay, that ridge is going to move off to the west, and that's exactly what we're seeing in all these models for the pattern changes for January 20th through February 4th, with with cooler air moving into northwest, and then we go a week in advance, and at this point it starts getting a little more difficult for the climate system to know exactly what's going to happen. But if you go all the way to the end here, February 25th through March 4th, and we see possible cooler air than normal extending into northwest, but that always changes. There's another website that we can see the actual individual. What's the individual? I mean hourly, or I think it's 6 hourly. No, it's 12 hourly forecast for what this climate model is actually doing, as opposed to a weekly average. And that's this one right here I'm showing you. So this is the climate model now, and this is its current analysis for this morning. So let me go forward in time here. This goes out, like I said, this one goes out about 30 days. So here's that ridge on the west coast. It's just these black lines that are going to persist for next week. This is Tuesday morning, weakening a little bit from this current week. Wednesday afternoon, and then here by next Thursday afternoon actually starts to bring some of that first low into northwest already on the 27th. I think that's too early, but the climate model does this a lot. And of course the climate model changes more every model run than the other models tend to. But we get this ridge starting to build to the west there. And then it actually moves that initial trough off to the east already and starts to build a ridge in here. Again, this climate model isn't the most reliable. It was designed more for long-term climate, hence the name. But it has been kind of getting the general pattern right, like, well, relatively right weeks in advance. So it's more designed for the really long term, like beyond the 10 to 15 day period. But again, then it's always not that accurate either. Anyway, I'm just showing it to you just because it's also indicating this long-term pattern change here with that big ridge over Alaska and the cooler air coming back into the northwest. Again, if this actually happened, this trough here is way too far off the coast for any kind of lowland snow, because we get a lot of onshore flow with this. The center of the trough is over water a lot, so we get a lot of this off over water. So that would be way too warm here for any. And this is on the 30th, and then the 31st. Here's that general pattern. It's big ridge over Alaska, really big trough. Again, there's so much of this trough though that's over water that if this actually happened from the climate system, this would be no snow at all in the northwest, because there's way too much onshore flow, way too much of that trough over water. But what this pattern does do, I'm not sure if I looked at this one yet. This is one from last night. It actually cuts off this ridge, and again, I wouldn't trust this that much, but it actually cuts off this ridge over the south part of Alaska, which essentially allows low pressure systems to move across the ocean. If that happens, then we get more onshore flow here, and that doesn't necessarily favor any kind of snow events in the northwest. But if that ridge strengthens, like, I think I looked at this before, but I don't know for sure. If that ridge maintains itself over the ocean, let's see what it does. Yeah, it doesn't really do anything in terms of snow here. It kind of builds that ridge back in. This is now February 8th. Alright, so there's really no point in looking at this anymore, probably. Let's just see for fun what it does here. It builds that ridge back over the west coast, okay. Alright, not anyway. I'll look at it until the end here in the video, just for the fun of it. But okay. Anyway, that's the long-term climate system. It really doesn't favor snow here in the northwest. It does have that same general pattern change, but it has that trough way too far over the ocean. That's not saying that it's going to be right. This is one of the most inaccurate models, except sometimes it does catch on to some kind of pattern change in the long term. But alright, so let's just look real quick at this. This is the GFS model is currently coming in. We have images out to 336 hours. So there's a jump here between 294 hours and 318 hours, but at some point between these two, it actually looks like this this area of low pressure that's coming off of the coast, because this ridge is strong enough, this area of low pressure, as it moves toward the coast, can actually pull some of this cold air. When we get low pressure coming in off the coast like this, and we have high pressure further inland like this, just the difference in air pressure can sometimes be enough to pull some of that cold air through the Fraser River Gap up in southern British Columbia in the Columbia River Gorge. So this actually does that. It looks like it pulls some of that cold air. Yeah, you see some of these colder colors through those into the northwest. I don't know whether it brings any if forecasting any snow with that. But again, we're missing some of those hours in between. But again, that's also the afternoon model. So I'm just looking at its current forecast. So this is a forecast of rain. This is the afternoon model. It does start bringing rain back here on January 29th. I'm gonna go back here to the beginning. So a week of basically no rain. It's again, it's just gonna be dry. We're gonna have sinking air. Some point next week we could have some air pollution, and then this low could start to bring a front with this lowland rain on 29th. Very weak front. So we'll see if that how strong that actually is and what the timing is. But here's the chance of rain increasing. This is on the 31st now, and it starts bringing that cold air in enough with these systems off the coast that it actually does start to bring some lowland snow, like Salem down to Eugene. Don't count on this actually happening. One is the afternoon model, two, this is way out there. So any kind of details we just don't know yet. So so this actually does bring some cold air in enough that we do have some snow around. So depending on how much cold air gets pulled in, if everything sets up right, that we get some cold air pulled in through the Fraser River Gap there, and the Columbia River Gorge there, we could have a potential of lowland snow again starting the first week of February. But it's too early to tell. I think that's all I'm gonna do for right now, and this is actually a little longer than I thought it was gonna be. But it just gives you an overview of how things might set up. And again, we don't know anything specifically, except that the pattern is going to change, increased chance of lowland rain, possibly some lowland snow in the long term, but no details yet, and if that's going to happen, how low the snow levels may go, how much cold air might move in, and so on. So, one more, okay. Alright, so that's it for now. I might give more updates as it gets closer. We'll see whether that's via video or via text. We'll see. Sorry, not text, but, well, I guess text, in the blog, along with some pictures. We'll see. If it starts looking like we're not going to see anything solid, snow-wise or sleet-wise or freezing rain-wise. We don't really get sleet that much here. In the long term, then you might not see any more about this. But I just wanted to give a very long-term overview. But it does look like it's going to cool down with at least rain coming back starting around the 29th through the 31st. And then possible snow events early to mid-February. We'll see. Alright, that's it for now. Alright, have a great day.